Basically, there's just a few things that you need to nail down. One of them, probably the most skill you need to do, is practice your reaction stoichiometry. If you didn't learn how to do that in pre-AP chemistry in high school, you need to make sure you can do mole to mole, grams to moles to grams, limiting reagent, and the amount excess in these reaction stoichiometry problems. This is basic chemistry, and in order to understand how we can predict how much fuel you need to get a certain amount of energy, you have to have some basic understanding that we can very easily, because of the laws of conservation of mass and energy, calculate, given a certain amount of fuel, how much energy. So the first step is reaction stoichiometry. Then secondly, you need to be able to quantify the quantity of heat given off given a certain amount of reactant. And what that means is, say methane gives off a certain amount of energy per gram. You ought to be able to calculate how much energy could be given off if you burn a certain amount of that particular fuel, such as methane. All right, you need to understand the function of the calorimeter, what it's for, how it works, and that sort of a thing. And then the calorimeter technique actually is the way that we determine how much heat is given off for a particular chemical reaction, how much heat is given off or taken up, depending on the temperature goes up or down in the water surrounding the calorimeter across the chemical change. So you should understand that that's how we get those heats of reaction. And then you should also be able to use bond energies to predict heats of reactions. So this would be like the experimental way of getting a heat of reaction, and this is the theoretical way of getting a heat of reaction, and you ought to be able to do both. Then the details about the fuels, you should recognize that coal and petroleum both are mixtures. Coal is a solid mixture. There's different types of coal depending on the pure substance that are in that coal, and we can break them down in certain grades of coal, anthracite or lignite, that sort of a thing. But even within those grades, there is still a mixture. Same thing with petroleum; it's a liquid mixture. We can break it down in fractions, but within the fractions, we still have a mixture, and we get it into the fractions using a technique called distillation. So you should understand what I'm saying here with the liquid mixture, what the fractions are, and how distillation works. And then because we have certain market demands more for gasoline than for the oil or for the smaller gases, then we have ways of, once those fractions have been separated, of cracking, either making the longer chains smaller, or reforming, making the smaller chains bigger. In both cases, in the cracking, you can use just heat or a catalyst. In the reforming, making them bigger, we use catalysts. Then reformulating the gasoline, that's, once you get the gasoline, then at the refinery, they're going to mix it with some oxygenated compounds. They're going to have a certain percentage of octane or certain chain lengths in order to get the right kind of burn that you need to optimize your engine. And then at the very end, we talked a little bit about alternative fuels and conservation, so you should be aware of those topics. So that's basically it's 20 questions, multiple choice. The skills and the math that you need to be able to do are basically the reaction stoichiometry and the bond energies. So you need to be able to work about 3 or 4 problems, and the rest are just kind of general information questions.